Hello students, in this video, after studying the rainfall, all the parameters which is related to the rainfall, here we are looking after the second process which is involved in a hydrologic cycle, that is the runoff. After generating the amount of a precipitation on the surface area, the part of the water which is generated and which is flow above the surface without any losses, this amount of water is known as a runoff. So here we are studying the various types of a runoff as well as the factors which are affecting on the runoff. Up to this, we got all the information about our one of the important process which is involved in a hydrologic cycle. Now, from this process or from this precipitation, the water which is generated or which is available on the surface, sometimes it is available under the surface. So the surface amount of the water is termed as a runoff. In previous slide, we had also defined this runoff process. So runoff is the part of a precipitated water. See, this reaction and this process are totally runoff process is depend on the precipitation. Precipitation amount or the precipitation mm, water that will be available on the surface that only gives us the amount of a runoff. So during this runoff, some part of a water will get infiltrated, some part of a water will get evaporated. So remaining water, amount of a water is termed as a runoff. The portion or the part of a precipitated water which can be available on the surface without any losses is known as a runoff. That we had already defined this runoff factor. So let's see the how many types of runoff are there. Types means what? The surface runoff just now we had defined, which is available on the surface but we without any losses, just flow out, just discharged out is known as a surface runoff, or it is also called as a direct runoff. That again and it ultimately finally it meets to the ocean and it meets to the river, it meets to the lake again. Next is a subsurface runoff. See, after falling the precipitation on the surface, the some part of a water will get infiltrated. If you remember in third chapter, water requirement of a crop, we had studied the soil moisture irrigation relationship. In this, we had studied that the part of the water which can be infiltrated and which can be available in the root zone, which can be successfully in through this zone, the plant roots can get the water for its nourishment. This portion again under this portion, the amount of the water which is available, which can be extracted by the capillary action. So in this process, the water infiltrated, the part of the water will get collected and will get stored successfully. So when the water will get infiltrated under the ground and that water can be used in the future for the for the nourishment of the plant. So this is called as a subsurface runoff. And groundwater flow or a base flow is nothing but when if the soil is the permeable, the soil is permeable, subsoil means the underground soil is a permeable one. So the water will directly discharge and water will directly flow down under the gravity action and it meets to the groundwater level. So the percolated water is known as a groundwater runoff or base flow. It is also known as a base flow. So these are the types of the runoff. Now let's see the which factor that are affects the runoff. So very first factor is the precipitation characteristic. Precipitation characteristic means it includes the intensity of a rainfall, it includes duration, it includes direction of a rainfall, forms of precipitation, then it includes evapotranspiration process also. How? Let's discuss. See, if the intensity of rainfall is more, means the runoff value is also more. If intensity of rainfall is less, then the runoff is also less. The duration of rainfall is more, then runoff is also more. Then runoff, if the forms of precipitation, if there is a snowflakes or if there is a hail is there. So the hail means the bulb or the lump of ice. So again, for it's required to melt or it's required to convert this part into a liquid section. So uh, in this type or in this form the runoff will be less, and if the form of precipitation is in a rain or it is available in a what do you say, the sleet form, then the runoff will be more. So likewise, this precipitation characteristic affects the runoff. Next is the soil characteristics, or we can term it as a subsoil strata of the earth surface. See, this can be considered it as a geological characteristic of spacing also. If the type of a surface soil and subsurface soil has the permeability characteristic, then the water will get stored in this type of a soil and the runoff will be reduced. If the soil is not permeable, then the runoff will be more. If the rocks have fissures or they are porous one, then most of the water will be lost by way of a seepage and surface runoff will be very small. So likewise, these geological and these soil characteristics affects the runoff. These are the same. Then we have a topography of a catchment. The runoff depends upon whether the surface of catchment is smooth or rough. If the surface slope is steep, water will flow quickly and the absorption and evaporation losses will be less, resulting in a greater runoff. If the catchment is mountainous and is on the windward side of the mountains, then the intensity of rainfall will be more and the runoff will be also more. If there is a flat surface, if there is undulation of a slope or undulation of earth is there, then the flow of runoff will be obstructed or the runoff will be less. Then we have a orientation of a watershed. That means the see the facing and the direction of the basin towards the sun. That this is known as the orientation. So this orientation affects the evaporation and transpiration loss by influencing the amount of heat received from the sun. The north and south orientation of watershed affects the melting time of a collected snow and hence the runoff will be affected. Similarly, in mountainous watershed, the windward side of the mountain receives a comparatively higher intense rainfall than the leeward side and hence runoff will be affected. Then we have a size and shape of the catchment. So this shape and size of a catchment also affects the runoff value. See, the more intense rainfalls are generally distributed over a relatively smaller area. A stream collecting water from a smaller small catchment area is likely to give a greater runoff intensity per unit area. In the case of very big catchment, uniform rain seldom falls over the entire area, with the result that only a very few tributaries of the stream feed water to mainstream during a particular storm. Thus, a runoff intensity of a larger stream per unit catchment area is lesser. So according to this, we have two shapes of the catchment. One is a fan shape and second one is a fern, that is leafy shape. So in case of a fan shape catchment area, all the tributaries are approximately of the same size. Such catchment gives a greater runoff since the peak flood from the tributaries is likely to reach the main stream approximately at the same time. In the in another case, that is in a fern leaf type of a catchment area, the tributaries are generally of a different length and meet the main stream at the regular intervals. In such a narrow catchment, the peak flood intensity is reduced since discharges are likely to be distributed over a long period of a time and hence the runoff will be affected. So depending upon these all factors, the runoff will be affected. Then we have a temperature, wind, humidity, which also affects the runoff. If the temperature is low, the ground is saturated and frozen one, it gives rise to greater runoff. If the whole of the stream freezes, the peak floods will be reduced, so runoff will be also reduced. On the other hand, if the temperature is high, if the greater and the velocity give rise to greater the evaporation loss, then the runoff will be reduced. Likewise, uh, there are so many factors which are affect the runoff. Thanks for watching this video.